thank you for being here today. To kick off the event, I'd like to introduce an important person for this event, and for many of you, has really helped us make this happen. So I'd like to introduce the Dean of the College of Engineering and Computer Science, Ghassan Kridli.
Thank you, Dan, and thank you everybody for being here. I would like to start by welcoming you all to this event, and a special thanks to our hosts, Hitachi, Astemo, and Global Automobility. Thank you all for being here and for featuring our college in your program.
Thank you, Dean. You know, it's refreshing to me. I've talked to the Dean a couple of times in the last month about this, and every time we get to what are you the proudest of, what's the thing that we should be highlighting, it's always been the students. It's the same thing. We have the best students. And I think it's cool that a dean would not want to boast about other things and really be proud of you guys. So good morning, I'm Dan Keelan. I'm the publisher of Global Automobility. It's my honor to welcome you to this beautiful campus. A little bit about this place. U of M Dearborn, according to the US News and World Report, is a top-ranked university. The institution serves 8,100 students, nearly half of them first-generation college students with high school entering average GPAs of 3.7. It's a unique place, a fully commuter campus featuring 4 colleges offering undergraduate, graduate, and PhD programs. Today's panel discussion is part of a series. It's focused on the future of engineering careers, the education, the industry, and the government integration and participation. It includes interviews like this panel discussion and interviews with students who are part of associations and teams and clubs. All of this will be shared in our digital channels via video and audio, shareable links, social media, email, and the event is being captured today for future video and audio release by our partners at Detroit Media Productions. A couple people I want to thank before I sit down. Again, the dean here, Dr. Kridli has just been a great facilitator, a great sponsor, brought together the panel, brought together the students. Philip Emma, who couldn't be here today, founder and CEO of PSN Technology, which is a Dearborn-based technology services company, who has functioned as like a community connector for us, working behind the scenes, but doing a lot of what we needed to get done. And a special thank you to U of M Dearborn's Vice Chancellor, Ken Crittenville. For our team, Ken has been a great champion of this project. His belief in what an education in engineering can be, his apparent pride and belief in the University of Michigan Dearborn has been apparent at every interaction, and we could not have done this without your support. Thank you very much. And finally, Astemo. They've been just a great group to work with. They have supported us financially. They've supported us in other ways. Sam Skolarski, HR specialist, who if you haven't met, you should, because not only is she a very nice person to talk to, but she's your connection to jobs, which is something we're all interested in. And she works for a guy named Rick Curry, who has been just a huge champion of everything that we're doing. Rick is not here today, but I want to thank him. Rick is the Senior VP for Human Resources at Astemo. I'll turn it over to John. Thank you.
Fantastic. Well, let's give the panel and Dan and everyone a quick round of applause before we get started. Let's get started with our first question to John Cristiano. Can't see you over there. I can see you now. Okay. All right. The first question is, what strategic initiatives has CECS implemented to enhance student academic and career success?
Great. Well, first, thanks to you, John, and to Cindy, and to Dan for being here today and giving us this opportunity. I think I talk about this in a couple different ways. One is in terms of how we support students while they're here, You heard a little bit from Dean Kridli about how we educate them, and then also about how students can take the initiative to kind of personalize their experience. So a couple initiatives that we've undertaken in the last few years. One is to establish an engineering learning center. So this is a holistic approach toward helping to support engineering students' success. So it's everything from career coaching to exam preparation to studying and a lot of these are tutored by our upper division students. So we have a relationship that's formed between the students that are doing the tutoring and the students that are there to learn. So that's helped a lot in terms of students becoming more comfortable and successful by learning from folks that have been through it already. A second thing is with respect to transfer students. So we have a number of transfer students that come to the college, many from Henry Ford College next door. And so we've done some outreach to be able to help create a sense of belonging and make the transfer from community college across the parking lot to our campus easier. So we've involved them in activities and making it such that when they come here, it's a relatively seamless transition. In terms of how we educate students, you heard from Dean Kridli about project-based learning and the entrepreneurial mindset. So we're working very hard to systematically integrate both PBL and EML into each of the classrooms. So we're ensuring that all students that go through any of our undergraduate programs have 4 experiences, at least 1 per year, in courses that are taught through a means to create a curiosity amongst them so that they're learning about, or they're questioning and having the opportunity to not just work on a bounded assignment, but an open-ended problem where they can look deeper to understand what the real issue is. Try to make connections with this problem to other disciplines or other factors that are going to influence the solution. And then finally, focusing on creating value. And we find that the focus on these things help to really make it such that students can talk about these experiences with employers and help to be able to explain the value that they bring to a company. Last thing I'll say is about personalizing sort of the experience. We have a program called the Grand Challenge Program, Scholars Program, and it gives the undergraduate students the opportunity to focus on a grand challenge area. The National Academy of Engineering identified 14 grand challenges. We're a little bit more flexible and allow students to determine their own grand challenge. And that's a common thread that we help to allow them to create throughout their undergraduate program so they can focus on a topic like clean water or energy and things like that. So it's about being able to personalize their experience. So we support students. We're working to integrate better ways to teach and prepare students for industry, and we allow them to personalize their experience while they're here.
Wow, it sounds pretty exciting when you think about that, to not only just get your education, but work on what you're passionate about. That's pretty cool. All right, Dr. Mohammadi, what is the relationship between mobility and robotics? It's a 2-part question. And are academic programs changing to address this?
So basically, robotics without mobility would be meaningless because robots at the end of the day are agents that move around. Whether you've got a mobile robot with wheels that basically goes on the floors of the Amazon basically warehouses, or whether we've got some industrial manipulators in Ford Motor Company doing welding on the cars, they're moving around. But the thing is that given that we've got these new basically stream of technologies in terms of different sensors like LiDARs, different types of actuators like modern electric motors, they're also making their way into our lives in terms of service robots. So for instance, mobile robots that can go around, help the elderly, and even having basically conversations with them. We've got an expert in affective computing and human-robot interaction, Dr. Alsaid, and she would be talking about these in a few minutes. But basically, all these technologies, along with the intelligence that comes through AI and advanced numerical algorithms, would basically make these robots a very fundamental an inseparable part of our experience as humans in society and the way that we do work. Industrial, manufacturing, every aspect of our life would be impacted by this basically fusion of mobility and robotics.
It's huge. And how are academic programs changing to address this?
So basically, we need to, of course, prepare our students and give them the knowledge base to be able to basically relate different and various domains of knowledge basically together. Because robotics is a multifaceted basically area. The students need to have a good understanding of the underlying basically algorithms. Like perception algorithms, control algorithms, and at the same time they need to have a very good hands-on basically set of skills in terms of integrating different parts together to create a robot or give the robots new capabilities like being able to assemble a LiDAR on top of mobile robot, or basically changing the electric motors inside a malfunctioning robotic manipulator. So therefore, the university programs, the new academic programs need to basically have an emphasis on both theory and also practice. Mm-hmm. And just as Dr. Cristiano was saying, our school is particularly very well prepared to give the students both of these experiences through the project-based learning approaches, which is the PBL. Because we usually, in the PBL designated courses, we give problems to our students that are open-ended, and the students need to have a very good grasp of both theory and practice to be able to handle these projects, and these will enable them to basically be stars in industry.
That's beautiful. Dr. Rawashdeh, what do you see as the most critical skills that engineering students need to develop to succeed in a rapidly changing technological landscape?
I think it goes beyond just the actual course content and the current technologies, right? Because it's always changing, like you said. I try to, and I think it's important to, it's the communication skills and the kind of the soft skills, but then one of the most important ones being the kind of the lifelong learning attitude, right? Like, I'm teaching you this now, not this particular microcontroller or microprocessor that I'm teaching you now, but like how to use it, how to sort out problems so that like 10 years from now, that particular chip is obsolete, but what you've learned and how your detective skills, your development skills, right? Your attitude towards development and troubleshooting, that's kind of what you pick up, right? And so we try to teach beyond just the material, but also kind of the lasting skills that you need, and then also try to instill the kind of the curiosity to keep up to date, right? Like, if you're going to be a computer engineer, you better know what's coming out every year, right? And so on. Mm-hmm. It's just, we can't teach you everything now. It's changing anyway, and you have to kind of become the type of person that keeps track and kind of has that curiosity.
Yeah, the dean was talking about the fact that, University of Michigan doesn't spoon feed the children. You come in and you have a mission and goal for yourself. And the University of Michigan Dearborn helps you with the skills to implement that.
We try to guide them to the aha moment, not just tell them what it is, right? Because that's kind of where you get the lasting effect.
Mm-hmm. Exactly. Dr. Alsaid, how do you integrate ethics into your teaching, especially in the context of rapidly advancing technologies like AI and automation?
Yeah, that's a great question, and I'm gonna touch on 2 points mentioned by Dr. Rawashdeh and Dr. Mohammadi. So first, ethics is at the core of my teaching philosophy. I truly try to emphasize to students that they carry a significant responsibilities as engineers and as designers, making sure that their work is ethically responsible. So I integrate that into different aspects of my teaching, from class discussions to readings, assignments, and then critical evaluations of different designs, or critical evaluations of their own like class projects at the end of the semester. But like Dr. Mohammadi said, technologies are becoming integrated in every single aspect of our lives. And you want to make sure that these are inclusive, these are ethical, there are no biases, which is the case of many of these AI technologies. So, for example, like one of the things that I like in, like when I'm teaching, one of the case studies that we go over is, and I don't know how many of you know this, but women are so much more likely to get injured in car accidents compared to men. And if you like look at the reason behind that, it's because the average car was designed for the average man, meaning that women are being excluded from the design and therefore they're more likely to get injured. So this is one example that we go through, and then like other examples like Amazon's AI resume algorithm, resume selection algorithm, like these facial recognition models basically that are very biased and what's not. And I really like students to be conscious about these when they see more and more examples of very well-intentioned technologies that did not go as planned. I think they develop this heightened sense of awareness that my work is significant, and it's significant in every step of the way. And then touching on what Dr. Rawashdeh said, it's that continuous learning thing. So I try to make sure that they know that it's not a one thing, like you don't design this product and leave it, put it out in the world and like just watch. It's an iterative process. So it's okay if like a few years later you realize that, oh, maybe like we could have done it better. You can go back and always reassess and reevaluate the ethical like aspects of your design, basically. So yeah, I try to make sure that this is something that they always keep in the back of their mind. From like maybe we don't get as much on perception algorithms, but we talk a lot about what it means to have a representative sample, what it means to consider different populations, what it means to make these technologies used or usable for as many people as possible, to hopefully, prepare them for their roles as designers and engineers.
Yeah, you have to, as you're designing, you got to put the end user in mind, right, to make sure it's working. And ethics is a big deal. That's a whole different thing altogether. One other question for you, Dr. Alsaid. How do you see conventional agents and technologies like LLMs influencing engineering and design education?
That's a really good question. And I say this, we just had a panel like 2 weeks ago here on campus that had experts, like academic experts, industry leaders, and a bunch of students who all kind of sat down and talked about how LLMs and AI has changed their lives over the past few years. And it was like just fascinating how many different opinions people shared and how like it changed the like work of so many people. And I teach a class on research methods in human-centered design engineering. So I've been reflecting on how AI has changed my life, both as a researcher and as an educator for the past few years. And I think it's a like transformative tool if used appropriately. I've been using it as a brainstorming body, basically. I've been using it as an editor. I've been using it as like an iterative prototyping tool. The opportunities are endless, basically. And I'm very optimistic, and I try to encourage my students to always explore the possibilities with AI, as long as they know its limitations and they know how to use it responsibly. Because it can push what's possible and empower them to think about things differently. It can just make the overall work process so much more productive, efficient, and like together we can get a lot more done if used appropriately.
Oh yeah, I mean AI can be very helpful but very dangerous, right?
Absolutely.
Cindy? Yeah.
Now we're going to take a look at focus on activities in student organizations. I'm going to start with you, Dr. Cristiano. How does involvement in student organizations contribute to personal growth and career preparation?
So I think to pick up on what we talked about before about passion and students being able to translate things from the classroom into the real world, the student organizations and the activities available on campus are a good example of that. There's a multitude of different clubs and organizations within the college and across the campus that students can avail of themselves to pursue an interest, see if there's something that they're passionate about, sort of to kindle their passion. And also to start thinking about, developing their brand. What is it that what set of experiences do they want to incorporate into their undergraduate education that will help to market them? So competition teams are some of the ones that do, I think, the best job at this, at least as far as taking classroom experience. So whether it's the Formula Combustion, the Formula SAE, Electric, the Intelligent Systems Club, the MASA group, which is our rocket group, they all get a lot of really good experience in taking what they've learned in the classroom and applying it into the real world. What works, what doesn't. They're exposed to working in teams. They have leadership opportunities. They have ways of being able to get a set of experiences that supplement maybe some of the work-based experiences they may have through internships and co-ops. And what we find is that, not surprisingly, I guess, these students are very highly valued by industry because of the experience that they've had. And so it gives them an opportunity to apply their technical skills and then grow through some of the areas of leadership and teamwork that are really important for them to have those skills as they go into industry. So big believer in encouraging students to take advantage of the opportunities that student organizations provide to explore your interests and your passion and to find one and to use it as a way of helping to achieve your goals.
It's interesting. My degree is not in engineering. I have a heavy interest in engineering because I come from an engineering family. Parents, brothers-in-law, sister-in-law, sisters, all of them are engineers, so it's in my blood. But I can relate organizations back to theater, which was where my degree was. And I found when we were working together on something, it imprinted so much more in your mind. And your thought process outside of the classroom is often different than sitting in a classroom. And that experience is incredible. So.
And getting to work also, I mentioned that the teams often involve students from other colleges, whether it's College of Business to help some of the financial or project management type things. So there's also that opportunity to cross outside the College of Engineering and Computer Science to other.
So you're not only thinking outside your own box, you're bringing in other people to help you think further out.
Correct.
Yeah, great. Dr. Alsaid, how do you bring real world problems into the classroom to enhance your students' learning process?
I think this is like the foundation of many of the programs and classes at Dearborn. And I truly believe that students learn best when they get to work on real world problems and try to address real world challenges. For me personally, I try to keep it as relevant as possible. So for example, I do have a funded project from Toyota Motor Company. And one of the aspects of that project is to build different human-machine interfaces for different ADAS feature or advanced driver assist features. So things like adaptive cruise control or blind spot monitoring. And the challenge that these HMIs or human-machine interfaces currently have is that they're kind of all over the place. So you have to do a lot of cognitive workload to find what you're looking for. And one of the things I'm gonna do is have students work on this challenge as part of their final class projects, where they get to design and evaluate different ideas on how to consolidate these HMIs and make them as user-friendly and intuitive as possible. So that's one part. Then the other thing that I try to do is to always reflect on my experiences both in industry and in academia, bring current world problems or current challenges that I'm aware of to the classroom, and kind of just coach students or guide students to think beyond their technical solutions to how these can be integrated or be translated into something usable, basically, in an industry setting or in a more realistic setting.
So the better you teach your students, the easier it is for us lay people to slip into things and just use them.
That's my goal.
Okay, another question for you. How do you incorporate these current advancements in AI, such as large language models, into your research on driving? And how do your students contribute to and benefit from this work?
Yeah, that's a good question. So again, I'm gonna talk about that research methods in human-centered design engineering. So one way I try to integrate these technologies is by just raising awareness of what's out there, because AI is everywhere, and if you're not aware of what exists, you're at a disadvantage. So I go from like websites or tools for literature reviews, how to use these to advance, like to speed up your literature review process. Maybe you don't have to spend like 1 month just doing the literature review. You can now do it in a few days and get the same place that you would with like a couple of months review. Then I maybe coach them through like how to do experimental design with AI's help. So brainstorm, like exchange ideas with AI tools, see where you get. Be critical about it. Like, critical engagement is so important, so I try to integrate that as well. And then more broadly, like we currently have a project in collaboration with Dr. Rawashdeh actually, where we're looking at how we can use these pretty clever LLMs and pretty conversational agents to be placed in the car as a mitigation strategy for passive fatigue or drowsiness. So, for example, if you're driving on a long road in the middle of the night, it's pretty exhausting, and you get tired, you get drowsy. So, how can we make these AI agents act as a passenger or co-pilot to keep you engaged? And what are the specifics of these conversations or exchanges that create the best, basically, intervention strategy? So I think it's like a process of integrating AI throughout the entire research, teaching, design.
I want you to work on highway psychosis. That's what I call it. That's probably not the real name, but when you're on that road trip and you're over the 2-hour mark and your eyes just start glazing over. I don't know if you need shock agents in the car seat or a burst of cold air in your face, but that would be helpful.
That's actually one of the interventions, is like seat vibration.
Oh.
Yeah. Little buzz. Yeah.
But keep me posted on how that goes.
No, little pins. Okay, Dr. Mohammadi, provide 1 or 2 examples of undergraduate student-led projects at U of M Dearborn regarding robotics, and how does the experience obtained by working on those prepare students for a new venue of that robotics integrated society?
Absolutely. So one of the very interesting projects that I was working with an undergraduate student this summer was focused on, again, integration of mobility and robotics. So the project was focused on building an autonomous blimp. So what is an autonomous blimp? It's basically a balloon, hot air balloon, or basically a helium-filled balloon, and then you've got a UAV attached to it. Of course, with certain geometric arrangement of the basically rotors of that UAV. And then it should be able to go around, gather some information, let's say the traffic situation, or basically crop monitoring and things like that. And the advantage that they provide in comparison to the traditional UAVs is that they're much more energy efficient, because the UAV, I mean, the blimp doesn't have to carry its weight. You don't have to spend energy on that. So it can stay up in the air for a longer amount of time. And basically, the student that I was working with, actually, I knew him from one of my classes, Applied Dynamics, EC 347. And one of the problems that we solve with the students is basically on modeling the forces and the torques, moments, all these things that you see in traditional dynamics courses and how they impact moving objects. In this special case, it was the blimp and the autonomous blimp. And then it turned out to basically a more basically complete research project during this past summer through the support of the summer undergraduate research experience program that we provide to our students at UM Dearborn. It's called the Shore, and I'm wearing the hat of Shore. And one of the great things about these research experiences is that they make the students active problem solvers. And this is what I believe that the industries in Michigan and across the nation need. They want engineers that can actively solve problems, that they can solve open-ended problems, things that are not traditional, because as we discussed, we are living in a society that is very fastly changing, and the students who become basically engineers, scientists in corporations, they need to be able to adapt very fast. These research experiences and these projects, because they're open-ended, they prepare the students to become active problem solvers.
I have a question about the blimp. Is it just mobility of the blimp and the ease of mobility that you're trying to achieve, or would it one day be able to carry a payload? Because you mentioned crop management, and I know one of the huge issues is how dangerous it is to take care of that. I know it's out, I can't think of the word, crop dust. It's such a huge, horrible occupation, and there's so many deaths per year. Would that eventually be able to carry a payload?
Definitely, that's a great idea, because the thing is that even before we had transatlantic basically flights from Europe to North America using, airplanes, we had huge blimps taking care of those. Of course, for some reasons, they got forgotten. But they've got this huge capability of now using the robotics and AI technologies, without having even a human driver, a human pilot, they can take crops from one place to the other. And I'm sure that with all these incoming AI and basically sensing technologies, blimps would also be safe. They wouldn't catch on fire, just what happened back in the early parts of the 20th century.
Is the gas the same inside the blimp?
It's the same, but the thing is that you can have a good, basically, network of sensors in your blimp, and if anything goes wrong, there's an also inside AI algorithm picking up on the faults, and basically then safety mechanisms come into the play.
And more importantly, there's no people on board. It's
people on board. It's just a crop. But even in that case, I'm sure that, because of course, if it catches fire, it would cause damage financially. But again, AI, all these technologies enable us to have much safer, basically, blimps.
Interesting. I haven't thought about blimps other than seeing over football stadiums in years as a form of
transportation.
Yeah.
Hitachi Astemo. We are pioneering a new future for mobility around the world. Advanced, sustainable technologies for mobility. With our world-leading advanced technologies, we're creating a happier, greener planet. Empowering mobility.
Dr. Rawashdeh, how do you engage your students in real-world problem solving? And can you share an example of a recent project that made a significant impact?
So a couple of ways. In our teaching, in our courses, I like to give students control over their learning. So we always have final projects. They get to propose. We go through a proposal phase and a design phase. So at that point, they have a pet project at home, or in some cases, they might have an industry partner that they're trying to deliver something to them. And essentially that becomes a more formal engineering project, right? So a lot of times, the engineering design process, we might cover different aspects of it in different courses. I could comment on the process, but it's essentially the inverse of the scientific method, right? And, it's hammered into us in schools. It's the scientific method, right? Observe, hypothesize, and test, and so on. If you think about it, engineering is the opposite route, where in science, you have the system and you're trying to analyze and understand it. In engineering, you're trying to synthesize a solution based on some want or need. So you form the concept, you You look at your options, you do your background research, you run some simulations, so there's a math and science component. And then you essentially, then you test. You might go back and improve, but so the design, test, and improve kind of philosophy. So real world, I think that's kind of the main character of real world projects. It's, in a course, you might cover the science part or the design part and so on. A project in a class lets you go through the whole process, right? And we do that in some of our senior level courses, and certainly in our senior design capstone classes. That's a kind of a formal design approach. So that's kind of in the classroom. There's also plenty of students that we hire for our research projects, and that's when that's as formal as it gets. We are the kind of essentially the startup company delivering the product to the customer that needs. So I guess that's kind of the industry research has that character. Federal funding can be more fundamental. But I'll give you, you asked for an example. We did a project for a local automotive supplier doing multi-object tracking using the laser sensors, so the LiDARs on the vehicle, for their autonomous lane change system, for example.
Oh.
So I hired a couple students for that, and we kind of wrote that algorithm and delivered it, and supposedly it's still in use. I still get questions every now and then about certain aspects of it. So students at Dearborn wrote some of that code that's on these cars.
I noticed a sticker on one of the tables. You said writing code, and it just sticks in my memory that someone put it there, and it said women who code.
Girls who code write the future.
Yeah, girls who code write the future. No, it hit me. I like it. So, but.
Yeah, my last comment was, so in the classroom and research project, also the student clubs get to have a formal project definition, and they have to do the engineering process to build a formal project. So it's a great experience for them.
Yes, that's great.
Dr. Mohammadi, how can universities and industry create innovative approaches toward collaboration?
Absolutely. So I can give you an example of a recent project that I was working on with Ford Motor Company. It's about a team of industrial robotic arms that were trying to paint a basically vehicle on the production line. Now, usually the thing is that these robots are trained using teach pendants, meaning that there's a human that would take the basically a robot arm, move it around, and teach it the sequence of the proper movement. Now, the issue with that is if one of the robots break down and the manufacturer has to bring in a new type of robot, or the vehicle make changes, then definitely we would like to find faster ways and automatic ways of computing the proper paths for these robots. Now, the Ford Motor Company was interested in the computational aspects of these algorithms, and for that reason, they reached out to us at UM Dearborn, and we basically designed the codes and algorithms for them and gave it back to them. Now, the very interesting thing is that it also created connections with Ford Motor Company, some of their active research engineers. I invite them to give guest lectures in my classes. And this basically gives the students of what's going on in the industry, what are their needs. So this connection between industry and university is great because it makes bridges with professionals that are actively working in the field. Also, there are some internship opportunity openings or basically job openings at Ford Motor Company that basically my connections at Ford would tell me about, and then I'll pass down the information to my students. So another thing is that these types of research would also make the teaching curricula up to date because they get informed by the most recent problems that industry is actively working on and basically have challenges about. So hopefully this might have given you some answers. But
oh, absolutely. Let's face it, I was talking to someone about the fact that the jobs I've gotten were all connections that I had with actual industry. So bringing people to the classroom makes all the difference in the world for the students getting jobs and also informing, like you said, the educational process.
And I also know that Dr. Rawashdeh also invites many industry people to his class, and maybe Dr. Alsaid, and she was also an engineer. She was working in the industry for a while.
Yeah, I love her story too. Yeah, yes. Well, Dr. Mohammadi, I have another question for you too. How can government-sponsored projects boost theoretical and hands-on research and teaching experience for students in universities?
So I will go back to what Dr. Rawashdeh was earlier saying. So the government-sponsored projects, specifically the ones that are sponsored by the NSF or National Science Foundation, they have got a foundational and basically more theoretical flavor, meaning that the university professors and their graduate students who are working on these types of research need to delve deeper into theory and come up with new ideas and algorithms. Now, these all would also enrich the educational content that we deliver to our students, because at the end of the day, no matter we like it or not, theories are everywhere. So a good engineer is one who also knows, to a good extent, the theoretical foundation of the field that they're working in, because it would enable them to basically narrow down their search for the best possible design. If they know, for instance, the theory of PID controllers, they know how to design these controllers so that they would not go unstable. If they want to forego the theory, then they have to go on trial and error, and it would basically consume a lot of their time and energy, and also have some financial impacts on the industries that they're working in. But that theoretical lens would also enable them to narrow down the search space and make them much more efficient in coming up with solutions. So I firmly believe that theory and practice go hand in hand, and they are the two wings that basically enable a successful engineer to fly high.
Yes. Yeah, knowing that if you don't go from the same vantage point, you got to start all over again. It makes all the sense in the world. Dr. Cristiano, what key partnerships does U of M Dearborn leverage to enhance the student experience?
So I can pick up from what Dr. Mohammadi was just talking about with respect to the industry relationships. So we have a robust set of relationships with industry across a number of different sectors, not just automotive, but others as well, bioengineering, et cetera. We look at these relationships with some common elements, but they're all tailored to the individual needs of the companies. Some will do research, some will be interested in visibility and the talent. They're all interested in the talent pipeline. So we'll have opportunities for them to come and host a day on campus, right, where they'll bring and be able to engage with students and provide some visibility for their company among students. Guest lectures into classes. Sometimes it's sponsoring of student projects or senior design projects. We have them come and they judge each year our senior design day. We have 50 or 60 projects across the different departments within the college. We have all industry judges that come and judge those projects and determine what they consider to be the best from the criteria that we provide. So there's a breadth of different ways that we engage with industry, and it's all tailored to be really what the company needs and what they're looking for out of the relationship. And we work really hard to be able to provide value and when we engage with them. I'll talk briefly about one other partnership that we have, and that's as a member of the KEEN, the Kern Entrepreneurial Engineering Network. The Kern Family Foundation was founded by Bob and Patricia Kern, who Bob started Generac. And so when he exited and sold that company, he realized that the things that he valued in engineers were not just the technical skills, but the things that we're talking about here, the the additional mindset that students have about how do you be curious, make connections, and create value most of all. And so the foundation is focused on a partnership of, there are I think 67 institutions nationwide that are partners in the Keen network. And we're charged with being able to integrate this into our engineering education. So there's faculty development opportunities that they provide, as well as a great network that shares a lot of information about engineering education and engaging with industry and making sure that the talent that we provide to the companies is what they need. So those are just a couple different ways we engage with students, or I'm sorry, with industry. One other thing I forgot to mention about the industry partnership is that oftentimes we will arrange with the company to provide opportunities for faculty to spend a summer in their company to be able to not necessarily work on any specific problem, but for the company to become aware of the faculty expertise, but also the faculty to be aware of both the culture and of industry, which obviously is different than a university, but also the challenges that they're facing. So that's another way that we help to try to create some of the bridges that Dr. Mohammadi was talking about for how we engage and work together.
Wow, that puts a fine point on it. Having people come in and you're basing the projects on what they need, which is pretty cool. And that Kern, I'll have some questions for you after about the Kern thing. Absolutely. So it's good stuff. Dr. Rawashdeh, have you worked with any industry partners on mobility?
So my research kind of split between federal and industry, so about half is industry, and plenty of times we have projects. So with Dr. Alsaid, the study on mitigating driver distraction, driver drowsiness, and having these conversational agents or other mitigations. So that's kind of ongoing at the moment. In the past, my general area is in robotics perception, so looking at using cameras on cars and laser sensors on cars to sort of solve certain either partial autonomy or full autonomy problems. And from a more fundamental research perspective, looking at the robustness, right? So the camera working in low light conditions, under rain, snow, and so on. So like adverse weather and lighting can really affect these vision systems. And as we approach counting on them more and more, we need to be confident that they'll be okay under those conditions. So yeah, in research, and then again, all these projects are mainly done by students that we hire, that we advise.
Those are some big problems too. If you think about driving in snow, I've always thought about that. Now the lines are covered, how line of sight, all that stuff. That's a really interesting problem.
And the dangerous part would be the algorithm not realizing that it lost the lanes, right? So the vehicle staying in autonomy and not handing over. At least it should know that it can't see and hand it over, right? But like thinking it can see and it's fine and not telling you about it, that would be really
That's
dangerous.
a big problem. That's a big problem.
So at least detection, right?
Thank you for that. Dr. Al-Shahid, how has your industry experience influenced your approach to balancing technical innovation with practical usability in both your research and teaching?
I think my years at Ford were absolutely invaluable in shaping both my research and my teaching. And just like listening to the examples that Dr. Rawashdeh mentioned, it's so easy for us as academics and researchers to go down these rabbit holes, focusing on have laser focus on a single aspect of something while ignoring the bigger picture. And there's nothing wrong with that. I am guilty of that. I enjoy it. I love it. I love understanding. But then, really, if you wanna equip students with the skills to succeed in their careers, and one critical aspect of that is to understand the bigger, broader impact of your design of your work and what's not. So that kind of trained me personally whenever I'm doing research, whenever I'm working with a graduate student on different research projects, is to always go back to that question, great, what is our practical implication? Fantastic, we created this algorithm that can detect lane marking with 99.999%. Yeah, why what's next, like how would that be implemented? One example is I do like a lot of research on affective computing. So we look at how to detect different emotions through different signals of the driver. And then like we always have to go back and be like, how is this gonna be used? Why, how can it make like the road safer, driving more accessible? What is like that bigger picture? So just by kind of reinforcing this kind of, or instilling this mindset, and I think like through my research has been really helpful. And then similarly for like teaching, I try to always bring examples from like when I was at Ford, things that I was personally like surprised to encounter, and how that was managed, how that was handled, because like just keeping that always in the back of your mind, I think is absolutely helpful, at least for myself, it has been. So yeah, I think it helped a lot.
Yeah, I enjoyed that when we talked originally about that story of you going into industry and it's like, and then now that you're back in academia, you can bring that experience like you did with Ford. I really appreciate that. It's really good. Cindy?
Dr. Mohammadi, how important is having a sound theoretical foundation in smart mobility and robotics, in addition to hands-on learning? Can students forego theoretical knowledge and only rely on hands-on?
Well, of course not. So,
I think you already answered that, didn't you?
Yeah, exactly. Because the thing is that, for instance, if I go back to the example of basically artificial intelligence algorithms for driving in snowy conditions. So if the algorithm fails, then the student should understand why it has failed. Of course, they can go around and play with the parameters in that basically training algorithm, but if they don't have the basics of the theoretical knowledge of how to train them, what are the impacts of those parameters of different basically components of these algorithms, they wouldn't be successful. They have to spend a huge amount of time, a huge amount of trial and error, and so much time, I mean, they would end up with no satisfactory answer. Even to say, I would say that practice without theory is blind. Theory without basically practice is paralyzed. They need each other to complement.
You know what it reminds me of a little bit? Like back in, I don't know, the 18th or 19th and 20th century, at the very beginning when no one communicated with each other and people were creating the same inventions continents away from each other. Had they been able to work together, maybe they wouldn't have wanted to, but if they had been able to, how would that invention have, how much sooner, how much better would it have been? So
Exactly, because at the end of the day, theory actually encapsulates a common body of knowledge between humans. And yeah, in a precise way and concise way, it also tells you, okay, so this is the correct way to look into problems.
yes, we've made the mistakes already. Start from here.
Yeah, exactly.
Dr. Cristiano, how does the college level, how does this college leverage its alumni network to help students build professional connections? Do you have a lot of alumni interaction?
We have a lot of alumni. We're very fortunate to have a very strong alumni set of alumni that want to stay engaged and want to be able to help. There are a number of ways that students have opportunities to engage with alumni. So we have an alumni advisory council that meets each month with the leadership of the college to talk about what's going on in the college, how they can help to evolve the curriculum to be able to make sure that it stays relevant. They participate in mentoring programs. We have the Wolverine Collective here, that mentoring collective here that helps to be able to connect both students with upper division students with lower division students, but also industry with students so that there can be a mentoring kind of role. We talked about some of the interactions that we have with industry, whether it's a day on campus. A lot of these industry relationships, not surprisingly, are facilitated by our alumni, right? So we would often, when we have these events, many of our alums are back here and they're engaging with students and they're part of the activity. So we really want to be able to provide those connections both through those networking opportunities, but also through their co-ops and internships or work-based experiences that students have. So obviously, again, alumni that are placed in companies are interested in students that come from their institutions. So they can be vital in trying to create the opportunities, or at least the visibility for students to get those positions. And it's sort of a self-feeding thing, right? As the students that are here engage with industry, get a chance to be able to see folks that have gone through and are now successful in their careers, they follow those footsteps and they want to be able to give back. And so we're very fortunate that our alums are very engaged and very interested in giving back.
I find the idea of the Alumni Council really interesting because I've always thought of alumni as mentors, but the fact that they come in and say, you guys are a little off on here, really connects academia with industry.
They are a sounding board for us. We often, as we're going through the revision of undergraduate programs and things, we will allow them to take a look at the curriculum and say, hey, does this make sense? What do we need? We just had, there are other advisory board meetings that the college has. They have a visiting committee. Each of the departments have an industry advisory board. So there's a lot of engagement at different levels for that kind of input. But the topic that we had at our visiting committee just about a month or so ago was talking about AI and how do we, what are the skills that students need to get in their education to be able to contribute? What are companies looking for with respect to AI? Is it anywhere from obviously development of algorithms to effective using? Why do you use it? For efficiency, for communications, and different things. So they're very helpful in being able to provide that kind of feedback and as a sounding board so that they keep our initiatives and our curriculum revisions rooted in the real world.
That's a great asset. What a great asset. Dr. Rawashdeh, why is hands-on learning so crucial for engineering students? And how do you incorporate it into your curriculum?
I think it's kind of the main way students kind of get lasting knowledge, right? Like all the information is out there online, right? And you can listen to it all day. Will it stick or not? It only sticks once you've built it and you've done it yourself, right? Plus, I think we learn from each other a lot, right? Mm-hmm. So in hands-on learning, you're working in a group of people, you get other ideas, you get competing ideas, it challenges your own ideas. And that's where your opinion forms in a much more stable way and a lasting way than hearing something that somebody said online or even read in a book. When you do hands-on learning, the group activity and the kind of anchors it, in a very interesting way, I think. It's a difficult. I think it's a very open-ended question. It took me a while to think about this, but I think that's kind of one of the major ways that hands-on learning is important.
That's it's a snapshot of life, isn't it? I mean, do you remember your mistakes? Everyone remembers successes because they come with so much joy and but the mistakes, you try to avoid them again. Right.
And then back when online programs were new, mm-hmm. there was discussions about what's the point of a brick and mortar school. You can just go online and take a degree, right? Mm-hmm. And the hands-on learning is one of the major answers.
Interaction.
Right.
Interaction.
And this brought something interesting to my mind. Basically, for instance, we have a team of NASA engineers, not a single NASA engineer who enables great achievements.
Yes.
The other thing I was going to say was to just give credit to the faculty, because when you're teaching and using project-based learning
yes.
or entrepreneurially minded learning, it's different because it's not. You have to be comfortable with allowing the problem to be open-ended and where the students might go with that. It's a different, not to speak for you, but it's a different style of teaching. It's not the traditional lecture where you're standing up and you're just doing PowerPoint or whatever. You have to be comfortable with the uncertainty of where this is going to go. And sometimes, it's uncomfortable with saying, I don't know, but let's figure it out together how we're going to do that. And so it's a credit to our faculty that they've embraced this, because it is different, it is a change, and it takes effort on their part as well.
But I find that with hands-on learning, the lecture hall is wonderful for what it is. But what you really remember is when you're touching things and doing things and problem solving. Maybe you remember what you heard just before you dozed off in the lecture hall, but and can apply it in the lab. But it's important. Okay, and that last question for for Areen. Here we go. What opportunities are available to students to enhance their marketability and their job prospects?
That's a great question. I wanted to add something to that.
Absolutely. Go ahead.
Yeah,
Go
please
ahead.
do.
Back to hands-on learning.
Yeah, back to hands-on learning. Just because I'm reading a book right now, it's called The Extended Mind. And it's fascinating. It talks about embodied cognition throughout. And just by simply, as you're learning something, learning a new concept, working on a new idea, just like when you're thinking, if you are walking, if you are moving, if you are doing something other than just sitting in that confined space, your performance improves significantly. And that shows you how much maybe better. I'm not honestly to be aware of the literature on how much better outcomes are. But just reading that book kind of kept me thinking about, we need to be moving our bodies in a way that's meaningful to the task we're doing. And
it's the grand idea in the shower. There you are, It's always when you're doing something else and working on something that extended answer comes to you.
Absolutely.
Yeah.
And then going back to your question, I think it was about what resources are available.
I can ask it again if you want.
Please. That'd be awesome.
What opportunities are available to students to enhance their marketability and their job prospects?
Yeah, so there are a few things. We do host job fairs often on this campus. So twice a year, once every semester, where we invite industry partners from different companies in the surrounding areas come here and visit and get to interact with students. So that's one. We do have a career advising office here on campus that helps the students navigating their career options. But then also within each program on this campus, there are advising opportunities where you get to interact with your advisor, academic advisor, learn about maybe the way I approach it. If someone asks me questions, I look at their resumes, try to identify potentially areas that can make them a little more marketable, or look at their overall story from before joining this campus to their degree to what they want to do after, and try to craft a perfect profile around that. So things like additional classes or additional certificates, or maybe some electives that can be more helpful. So that's also offered. But yeah, these are some of the opportunities.
I want to give us a plug. I mean, it's stuff like this that's exposing to our
100%.
Supporter, to Astemo, that they're interested in the new engineer, and they want to know what can they do to facilitate the learning process so that what they receive from you is even better than they hope. So.
100%, you're absolutely right. It's events like this, and I know Regina is working on, so I'm marketing your event now, on the Power Conference, and that's an annual SWE, the Society of Women Engineers conference that takes place on this campus, and they also try to provide opportunities, just like you said, for connections and networking of students and industries.
Can I just add one thing to build upon what Dr. Alsaid said? So there's also a little bit more formal career coaching. So we have professors of practice who are faculty members that have spent significant times in industry and are now end of career, coming back and getting into help with education. They prepare in the Engineering Learning Center that I talked about earlier. They often have office hours there where they can talk to students and give them some feedback and direction on their careers. And a lot of it is even just trying to understand, okay, I'm getting a mechanical engineering degree, I'm getting an electrical, what are all the things I can actually do with that degree?
Yes.
Right? So, I mean, it can be a foundation for other careers that are not necessarily technical within engineering, but also even just within engineering, what's the breadth of different things I can work on? So that's a really valuable way of helping students to understand. Of course, we do a lot of work-based experience co-ops and internships, and those are valuable to help prepare students. And I think personally that a lot of times it's as much about finding out what you don't want to do as it is about what you do want to do. So if you go into an internship or co-op and you find out that, gee, I thought this was going to be just a great experience, what I was passionate about and learning about, and you find out it's not, that's okay. There's ways to be able to, reshape your experiences or redirect your interests. But it's a lot better to find out about it now than when you've been there for 5 years and realize that this is not the career for you.
Mm-hmm.
And it seems to me, one thing I've learned from our publications and the podcast and this tour is that discovery in engineering, it's just so exciting. And I don't think a lot of people understand how exciting it can be. And to find something that excites you and keeps you excited and keeps you discovering is wonderful. And engineers are not boring people. They're excited people.
Let's give everyone a round of applause.